Hello everyone. In this video I am going to teach you the introduction to linked list. I am going to introduce you about the linked list data structure. Now let's see what is linked list data structure. Linked list means it is a data structure in which you can store the elements in non-consecutive location, non-continuous location or non-consecutive location. Suppose you are taking array, you are declaring array of size 5. Suppose I am creating an array of size 5. 1, 2, 3, 4, 5. Index are 0, 1, 2, 3, 4. This is array A. Now see, if you want to store some 5 elements into this array, suppose I am storing 8, 4, 5, 6, 2. How I will store it? I will store it in continuous location. That means in 0, then next in consecutive locations. I can't store 8 here, then 4 here, then 3 here. Like randomly I can't place. I should place in consecutive location. This is the condition in array. But in linked list, if you want to store, you no need to store in consecutive location. Suppose see, this is the memory. Now the memory is like this. Suppose these are the elements which you should store 8, 4, 5, 6, 2. I can store 8 here, then 4 over here, then 5 over here, then 2 over here. Like this, I can randomly place the elements. This is linked list. But pointer will point towards this. See, first this 8 means next it will point towards 4 like this. Then next element to 4 will point towards this thing, 5. Then after 5, 6 is there. Suppose I am storing 6 here. Then 5 is pointing towards 6, next element. Then after 6, 2 is there. So 6, after this it will point like this. This is the difference between array and linked list. Now see. Now let's see why we are coming to linked list. We have array data type structure, right? We can store elements in array itself. Why we are using linked list? That let's see. See. Suppose this is the memory location. This is the memory space of size 14. You can store in this up to 14 integer. Suppose see. Now I am creating an array of size 6. Suppose. Now see. Now I am creating an array of A of size 6. Now I am starting array A from this point. So 1, 2, 3, 4, 5, 6 till this. Till this memory location is allocated to A. Now see, index for A is 0, 1, 2, 3, 4, 5. Now see, suppose in this array A I am storing, there are 6 empty spaces, but I am storing only 3 elements in this array A. Suppose I am storing 8, 4, 3. 8, 4, 3. I have stored 3 elements into this array. Now see, suppose I am creating another array B of size 7. Now see, now I'll start array B from this place. Now see, it starts from here till 7 spaces. 1, 2, 3, 4, 5, 6, 7 till last space. This is allocated to B. You can store 7 elements in this array B. Now see, for this B index are 0, 1, 2, 3, 4, 5, 6. Now see, suppose in array B you are storing all elements in array B. Suppose I am storing 8, then 7, then 9, then 12, then 1, then 6, then 4. Suppose these elements I am storing in B. B array is full. Now see, now you have array A of size 6, but you have stored only 3 elements. There are 3 more empty spaces in this array. Now array B is full. Now you have stored all the elements in array B. If you want to store suppose one more extra element into array B, so I have empty spaces here. Suppose I want to put 7. Now suppose I want to add one more element 7. I can't insert 7 into this 3 spaces, but it's still empty, right? But you can't use. This is the drawback of array. This is the drawback of array. That is, you can't utilize the memory in array improperly. You have 6 spaces, but only 3 spaces are filled. Other 3 spaces are empty, but you can't utilize that space. So linked list is used for removing this drawback. How means, suppose see, in linked list, suppose I can randomly place elements in linked list. Suppose see, 8 is placed here, then 4 is placed here, 3 is placed here. So now suppose see, 8, 7, 9, 12, 1, 6, 4 is here. 8, 7, 9, 12, 1, 6, 4. This is placed. Suppose next element 7. 7 I can place here also, here, anywhere I can place randomly. 7 suppose I am placing here means the next element should point here. The 7 is after 4. So it should point like this. This is the condition. Or else suppose see, if you are storing 7 here means you should point 7 is after 4 like this. This is the condition. You can in linked list you can place element randomly. Here 8, 4, 3 you are placing in properly in ascending or like in continuous manner. In linked list you can store 8 here, then 4 here, 3 here like this. But pointer should be there like this. This is the difference. This is the thing to overcome the limitation in array. For this only we are using linked list. Now the other problem is see this thing. Suppose in this array A the size is 6. Now you are filling suppose 3 more elements into this array. Suppose I am inserting 7, 4, 3. These 3 elements I am inserting into array A. Suppose see 7, 4, 3. I have inserted. Now see. Now suppose I want to increase the size of array A. I can't increase. See. Now array A is full, and this is the memory location for array A, ending array A, and this memory location, this space is starting for B. No space is there to increase array A. You can't increase memory size of array A. So how to increase the size? For this drawback I am using a linked list. Suppose I want to increase the size. Suppose I want to put another element. Suppose 10. Suppose I am inserting 10 into array A. Suppose array A is full. Now I want to increase the size means you can use linked list. Now you can insert 10 over here. Here one free space is there. So I am inserting 10 and the pointer should point like this. After 3 it's pointing. So like this. Like this. This is the why we are using linked list instead of array for removing the drawback. Now see, now I am going to teach you the representation of linked list. See, now suppose I want to have 5 elements in linked list. See, suppose I am creating a linked list. I want to insert 5 elements in linked list. See, it is represented by nodes. What is nodes? I will explain. See, now this is the linked list. Second node. Suppose I am creating 4 nodes. See, what is node? This is node. This is first node. This is second node. This is third node. This is fourth node. Linked list is combination of nodes. Now see. Now in this you can store data structure. Suppose see, this all are the node. First node, second node, third node, fourth node. Now there are address for the nodes. Suppose see, I am having the address for this node is 100. Now let's say this address is 300. Now suppose let's say this address is 400. Now let's say this address is 900. Suppose. Now see, if you see in array, the array C, suppose like this means array of size 5 means it will have, suppose address is 100 means this address will be 104. This address will be 108. This address will be 112. This will be 116. It will be in equal interval by increasing by 4 values, 4 bytes. 100 plus 4, then 104 plus 4, like that. Plus 4. Interval is plus 4 in consecutive ways. But in linked list, see, this is 100, then 200 bytes are increased. Then here 300, only 100 bytes are increased. Here 500 bytes are increased. So this is not in equal interval. So this is the difference between array and linked list. Now see. Now these are the nodes. First node, second node, third node, fourth node. Now suppose you want to store a. Now there are arrows represented here. See. Now this is the representation of linked list. Now you want to store suppose data into linked list. This each node contain 2 parts. See. This is first node means now there are 2 parts in this. This is data part. First part is called data part. This second part is called pointer part. Now let's see what is data part. This data part can store data values into this linked list. Now see, suppose you want to store 7, 8, 5, 2. How, where you can store? In data part. This is 7, then this is 8, then this is 5, this is 2. I am stored in data part, these elements. Now see, now what is this second thing? This is pointer part. Pointer part means that pointer part stores the address of next node. See, the address of next node is 300. So the address of next node is stored in previous node pointer. So 300 is stored here. Then here 400 is the address for this third node. So 400 is stored over here. And here 900 will be stored because 900 is the address of next node. Now here 0 will be stored. Why 0? Because no node is present after this. So 0 will be there. Now why we are using this pointer, I'll explain. Now see. Now if you don't write 400 here, suppose see, 400 I'm not writing here, then this arrow will not point towards this thing. Next node it's not pointing towards here. Suppose if you write 900, 900 means it will point towards this node. To identify which is the next node, that's why we are using pointer. Pointer is used to store the address of next node. Now to find that this is the next node of this node. So that's why I am storing the address of next node over here. The address is 400, so I am storing 400 over here. So pointer will point towards this. This is linked list. Now see, now other pointer is called head. What is this head pointer is, I'll say. Head pointer is used to store the address of first node. This now 100 is the address of first node. So I am storing 100. Now this points towards this thing. Why we are using head? Because head is used to find which is the first node. You can't say this is the first node, this is the first node. You want to identify this is first node. To identify this, you are using a head pointer which points towards the first node. This is a representation of linked list. Now see, now how to write this structure of linked list as in code? Let's see. See, structure of this structure of a node contains two parts, data part and pointer part. So I am writing this. See, struct node. This defines the structure of a node. Now see, in bracket I will write first part is what? Data part. You can store the data values in it. So I am writing int data. Now int is integer. Now you are storing integer values into this data. So I am writing int, data type is int. Now see, the other part is called pointer part. So I should write pointer. Now you can name the pointer as anything. I am naming as next. Suppose the pointer name is next, I am naming. You can name as anything. So I am writing, see, pointer next. Now what is this symbol? This symbol is used to represent a pointer. If you don't write the symbol, that means it's not considered as pointer. So see, this is pointer next. This pointer is pointing towards what? It's pointing towards the next node which have the same structure as previous node. It contains same structure as previous node. It contains data and pointer as same thing. So I am writing struct node. So see, this is pointer next. This pointer points towards a node which have the same structure as previous node. So it again goes back and comes into this. So I have defined. This is how you should define write the code for defining the structure of a node. Let's see the memory requirement for this linked list and array. Now see, suppose I am creating an array of size 4, same as this. So see, I am creating an array of size 4. 1, 2, 3, 4. This is the index of 0, 1, 2, 3. Now see, now suppose I am storing same elements into this array as in linked list. There are 7, 8, 5, 2. So I am storing that same elements over here. 7, 8, 5, 2. Now see, this array name is A. Now see, how much memory is required for this array A? See, now you are storing integer values. Integer value means each integer takes 4 bytes. So see, now what is the formula means? It is size of each integer into number of integers, number of elements. So see here, the size of each integer is 4 bytes. 4 Then number of elements, there are 4 elements, 7, 8, 5, 2. 4 elements are there. So into 4. So it takes 16 bytes. 16 byte. Now see, same elements are only stored in linked list also. But let's see how much memory is required for linked list. See, now each integer values take 4 bytes, right? See, now there are two parts. Here only one part is there. For 7 you are taking only one part, and 8 you are taking only one part. But see here, for storing one integer value you are taking two parts, that is data part and pointer part in linked list. So see here, now for data part, see, this is for, now for this node how much is the size, let's see. There are two integer, 7 then 300. So see here, this is for 7 4 byte is there, then for 300 4 bytes. So combination total is 8 bytes. 8 byte is for single node, one node 8 bytes. So how many nodes are there? 1 2 3 4. So 8 into 4 equals to 32. 32 is the memory requirement for linked list. But in array, if you see, that is 16 bytes. So this is double of memory required for linked list is double size of array. So memory required in linked list is more compared to array. This is the drawback in linked list. Now I am going to teach you the time complexity taken for inserting an element into array and linked list. See, now suppose you are creating an array of size 5. 1 2 3 4 5, index are 0 1 2 3 4. Now see, suppose you are storing 7 8 5 2 into this array A. 7 8 5 2. Now see, now suppose you want to insert one more element. Suppose 9 you are inserting. 9 you are inserting into this array at beginning of this array. Beginning means at this part. So how you can insert? For that you should move this element to the next part. Then this element one step forward. This element one step forward. This element one step forward. Then how the, now 9 you should insert, right? Then how this array comes? See, now array A is like this. Now 2 is moved forward, 5 is moved one step forward, 8 is moved one step forward, 7 is moved one step forward. Now this space is empty. Index are 0 1 2 3 4. Now you can insert this 9 into this first empty space. So this is how you will insert element in array at beginning. So this takes how much time complexity? See, for inserting at beginning you will you should move all the elements presented in array one step forward. So if there are n elements, n is 4 here, n is 4. So you should move 4 elements one step forward. So time takes O of n in array. Whereas in linked list, let's see. Suppose you want to insert an element at beginning of linked list. How you can insert? See. So what you should do is you should create a new node. I am creating a new node. Now I should store data part. Suppose I want to store 9, insert 9. So I am storing 9. Suppose this address is, suppose let's say 500. Address of this node is 500. Now see, now how I should change? See, I should point, now this is the first node. I should make this as first node. Previously this was first node. Now I should make this as first node. So how to make? So I should point, this should be second node. Then I should point this thing towards this. How to point that? I should store the address of this node into this previous node pointer. So address of this node is 100. 100 should be stored in the pointer part of previous node. So in new node. So 100 is stored here. If 100 is stored, then this pointer will point here. Now see, now what change I should do? Head is used to represent the first node. But after inserting this at beginning, this will become as first node. So head should point towards this thing. Head should point towards this thing. How you can point? You should change the head value to the address of new node. Head equals to new node you should make. New node address is 500. So 500 is stored here. If you store 500, this will point this. Now you have inserted. So see how much time complexity has taken here. O of 1. In linked list at beginning, if you want to insert means O of 1, because no need to travel all the elements in this array. You are taking only single step. But if you see in In linked list it takes single step, but in array you have to move all the elements one by one. All the n elements you should move one step forward. This is the difference between linked list and this array. Now let's see the time complexity, time taken for accessing an element in this array and linked list. See, now what is accessing an element? Accessing an element means you should get the element which is present at given index. Suppose see, you have written 2. That means you have to find the element present at index 2. So index is 2. So here element present is 5. So it should return 5. So how it takes in array? See, the process is, it uses the formula array address. See, now it finds the address. Suppose for this the requirement is you should know the address of base. This index 0 you should know the address. Suppose let's say this address of index 0 is 100. Base address is 100. So you should calculate the address of index 2 because you want to find the element present at index 2. How you will find? See the formula. Address of index 2 is base address plus index into size. Now see, base address is given 100. Now index is the address of index which you should find. So the which address you should find, address of which index you should find? Index 2. So I am writing index is 2. Now what is the size? Size is you are storing data type is integer. Integer values you are storing. Each integer takes 4 bytes. So I am writing in 4 here. So see, 100 plus 2 into 4. 2 into 4 is 8. 108. 100 plus 8 is 108. So see, the address of index 2 is 108. So see, this each integer takes 4 bytes, right? So see, 100 plus 4 is 104, then plus 4 108, then plus 4 112, then plus 4 116. See, 108 is found by using this formula within single step. So time complexity for accessing an element in array is O of 1. But let's see for linked list how much time it takes. See, this is continuous. Continuous means the elements are stored in consecutive memory location in equal intervals, 100 then plus 4 then plus 4, like that, equal intervals. But in linked list, if you see, it's not stored in equal intervals. See, 100 then plus 200 is 300, then plus 100 is 400, then plus 500 is 900. So it's not in equal interval. So see, if you want to access this element present at index 3, suppose, now for this you should find the address of this node. How to find? If you know the base address, you can't calculate the address of this address of second index by using this formula. You can't find, because here it's represented continuous in equal intervals, so you have calculated, but here it's not in equal intervals, so you can't find. So how to access? For this you should create a pointer called temp. This temp is pointing towards the first node. Temp equals to head, so 100. Then this will point here. Now you should check. If you want to find the address of this node, means you should check. You should move the temp till this thing. So see, now temp should be equals to temp next. Temp is 100. 100's next is this thing, 300. So this value changes to 300. If you change this pointer will point towards this thing. Now temp equals to temp next. So 300's next is 400. So this 300 will change to 400. Now this will point towards here. Now you want to find the address of element present at this node. The address is 400. So you should return temp data. Temp data is 400's data is 5. So it returns 5. So how much time does it take? For this, suppose if you want to find the element present at last index, means you should travel all the elements presented in linked list. So it takes O of n. So time complexity is O of n for accessing an element in linked list. So this is the drawback in linked list. This array takes less time, constant time. But in linked list you should travel whole linked list, all the nodes. So that's all for today in linked list, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.